Hello Pre-Calc, this is a video for the 4.3 factoring lesson on factoring sum and difference of cubes and factoring by grouping. This video will just be on factoring sum and difference of cubes. So to begin, the bell ringer asks what 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed are. You're going to need to have these numbers memorized if you don't know them already. You should take a second to do the bell ringer by yourself and then check the answers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. It's also really useful to know 6 cubed and 7 cubed. You definitely want to have these memorized. 6 cubed is 216 and 7 cubed is 343. Why do we need to know them? Because they're really useful when we're factoring sum and difference of cubes, which is what this video is going to focus on, and it often comes up when we're dealing with polynomials. The second bell ringer question is, what is the cube root of 8? The way you want to think about this, think about square roots first. If I asked you, what is the square root of 16, the answer would be 4, because 4 squared equals 16. And square roots and squares are opposites. They undo each other. Similarly, the answer to the cube root of 8 is 2, and it's 2 because 2 cubed is 8. So a cube and a cube root are opposites. They undo each other. So 2 cubed is 8, and the cube root, if I took a cube root of both sides, would give me 2. Okay, next page. So flip to the next page. We've got, let me clear this. Okay, so on the next page you've got a variety of different factorizations on the page, and it asks you to record some patterns. I recommend trying to look at those factorizations and writing down patterns yourself, but we're not going to focus on that in this video. We're just going to jump straight to the actual patterns themselves. So sum and difference of cubes. If you have a cubed plus b cubed, the factorization is going to be a plus b times a squared minus a times b plus b squared. And this is a pattern you'll want to memorize, but I will teach you an acronym that can help you. So this is the sum of cubes because there's addition. The difference of cubes is a cubed minus b cubed, and the pattern is a minus b times a squared plus a times b plus b squared. So you'll notice for sum of cubes that this first sign here is a plus, and then the sign here is a minus. For difference of cubes, when we start with subtraction, so difference, the first sign here is a minus, the second sign is a plus. So it's switching signs. On both of them, they end with a positive sign. Otherwise, the two factorizations are the same. So an easy way to remember what the pattern should be is an acronym that we call SOFAs, and it lines up like this. S represents square A, so you're squaring the A value, which you can see here and here. O stands for opposite sign. So the opposite of what was originally given, so here we had a minus, here we had a minus. We switched to the opposite sign here with a plus. In the sum of cubes, we started with a plus. The first factor had a plus. The second factor has a minus. Then F in SOFAs stands for factors. This means that you're multiplying A times B. A is addition. You will notice we said that both of these second factors end with addition. And then the final S for sofas represents squaring B. So that's the B squared at the end. So the SOFA's acronym can help remind you how to do the factorization. Okay, so let's do some examples now. Let's clear the screen. All right, so example 1 is x cubed minus 27. So this is the difference of squares because it's subtraction here in the middle. And this is the pattern, a cubed minus b cubed. In order to factor it, we have to figure out what a and b are. Right? So our first factor is going to be a minus b, but we need to know what a and b are. To figure that out, take this first term, x cubed, and ask what is the cube root of it. Well, the cube root of x cubed is x. So our a value is x. I'm going to put an x here. Then our b value, we're going to take the cube root of 27. The cube root of 27, we want to have that memorized. It is 3. Because 3 times 3 times 3 is 27. So our b value is 3, so we're going to put minus 3 here as our first factor. So this minus is because it was the difference of cubes. All right, then for our second factor, remember we're going to use the SOFA's pattern. So square the a value. In this case, our a value is x, so it's x squared. Then use the opposite sign, so minus. Then f means multiply the factors, so a times b. In this case, our a value is x and our b value is 3, so this is 3x. And then a for addition, and s is square b. Our b value was 3, so we're doing 3 squared, and what's 3 squared? It's 9, so we can replace this with a 9. Now, do you have to write out SOFAs every time you do the factorization? No, but I've found that it helps a lot of students. Okay, so that was example 1. Let's take a look at example 2. Okay, example 2, 4x cubed plus 4. So the question is this a sum of cubes? It has the addition, but is 4x cubed a perfect cube? No, 4 is not a perfect cube, so it doesn't fit our normal pattern. But, as always, when we factor, the first thing we want to look for is a GCF. And if we pull out a GCF, which is 4, we get 4 times x cubed plus 1. Is x cubed a perfect cube? Can we take the cube root of it? Yes. Is 1 a perfect cube? Yes. Okay, so now we can factor x cubed plus 1 as a sum of cubes. So our a value we get by cube rooting x cubed. The cube root of x cubed is x because cube roots and cubes cancel. And then our b value is the cube root of 1, which is 1. Okay, so our factorization for x cubed plus 1 is our a plus b, so x plus 1, because that's the cube root and the cube root, and the plus sign because we're doing the sum. Okay, and then we're going to use the SOFA's pattern. So S is for squaring A, so x squared, O for opposite sign, minus, F for factors, and multiplying them, that's x times 1, or 1x, or just x, A for addition, and S for squaring the B value. 1 squared, and that's just 1. Okay, So our final factorization from the original, we can't forget about our GCF. So the final is 4 and then x plus 1 times x squared minus x plus 1. So that is the factorization for 4x cubed plus 4. All right, let's take a look at one final example. Let's clear the screen here. Okay, so example 3 is 64 plus 125a cubed. So we want to ask ourselves, is 64 a perfect cube? Yes. So our a value is the cube root of 64, and the cube root of 64 is 4, because 4 times 4 times 4 is 64. Is 125a cubed a perfect cube? Yes. The cube root of 125a cubed is 5a. Because 5 times 5 times 5 is 125, and a times a is a cubed. Okay, so let's do our factorization down here. So the factorization is our a plus b, so 4 plus 5a, and then s for squaring the a value. In this case, not 5a. Our a value was 4, so this is 4 squared. O for opposite sign, so minus. F for factors, multiplying them. That's going to be 4 times 5a. A for addition, and then s for squaring b. So that's 5a squared. Okay, now I'm going to erase the sofas so we can simplify this. So our factorization becomes 4 plus 5a, and then 4 squared is 16, 4 times 5 is 20, so this is negative 20a. And then 5a squared is 5a times 5a, so this is 25a squared. And that's our final factorization. Now, some of you guys like to change up the order so that the variable is always at the front. Would it be okay to switch the order here? Yes, because it's addition. If this was subtraction, however, you could not change the order. So let's say that this was originally a minus, and then our factors changed to a minus and a minus here. This order would need to stay. You couldn't flip them. So that's just something to keep in mind. The other thing that would change, of course, is this needs to be the opposite sign, so this would be a plus. All right, so in your packet now, there are some practice problems which you are welcome to do, and then check against the answers that I will post after I clear this screen. So here are the answers to practice problems 1, 2, 3, and 4. Pay special attention to number 4. 8x cubed is a perfect cube and 64 is a perfect cube, but you still need to take out a GCF first in order to fully factor it. So pull out the GCF first so that you get the correct final and complete factorization. And here are the answers for 5, 6, and 7. Again, we've got more GCF problems. So make sure you take out the GCF first and then include it in the full factorization. All right, that's it for factoring sum and difference of cubes. Make sure you watch the next video on factoring by grouping.